So hello everyone. I welcome you all to this question and answer session wherein we would try to answer the most frequently asked questions that you may have or you may have come across about graphs and graph databases. Today I have with me my close friend and the CEO of Softlink Information Systems, Sridhar Iyengar, who is also an expert on graphs and graph databases. So Sridhar, welcome to this session and thanks for joining in.
Thank you, Deepak. I appreciate it.
Thank you, Sridhar. So what I have done here is I have compiled a set of most commonly asked questions about graph and graph databases. Now, many of these questions probably we may have answered before, but then I thought that for the benefit of our audience and to make this Q&A session more valuable, I have included those questions as well. I hope that is fine with you.
Sure.
All right. So if you are ready, Sridhar, then we can start.
Yes, I'll do my best. Thank you, Deepak. Yeah,
all right.
We can start.
Okay, Sridhar. So the first question that is commonly asked is, what problems graphs solve?
Thank you, Deepak. I have a couple of slides which I would like to share at this point in time so that it becomes easy for the audience as well as us when I go through the answers. I don't think you have a problem if I share them, right?
No problems at all.
Okay, I think the slide has just come up on your screen. I hope you can see it.
Yes, I can see it very clearly.
Okay, so we can go. So the first question, I think you said, what problems graphs solve, right?
Yeah.
Okay, so the slide on your screen currently talks about some of the areas where graphs are extremely useful and where they've been solving the problems for us, especially financial crimes, where a lot of attention is there these days, and graphs have been doing a wonderful job, and graph databases have been used extensively. They also find use in drug discovery, recommendation engines, customer segmentations. These are the key areas where one finds it very difficult to mine information from the tons of data that gets produced by the technology and the transaction processing systems over the world. So cybersecurity is an area which is of concern to governments as well as individual enterprises, and graphs find their use there. Churn prediction, predictive maintenance, and search and master data management. Master data management essentially comes out of this requirement where companies buy each other out and mergers and acquisitions happen in large scale. So you need a master controlling system where your fields and the references to your names, they match across different organizations which may have been pulled in together due to major acquisitions and mergers that happen.
Okay.
So I would just want to dive a little deep here. We'll take you into a graph system where we'll try and show you how these usage of graph, and I'm trying to use a graph to represent their usage. So if I just click here and I expand this graph, I hope you can see it. So you find that I've used the Neo4j database here to try and explain or dive deep a little further into the different areas where graphs find their use or graph databases find their use. So here you can see that the areas where graphs get reasonably extensively deployed are some of these. And let's dive a little deep into the financial services, because that's an area where a lot of people have and been using graph and have asked several questions. So you find graphs being used for general data protection requirement, anti-money laundering, financial risk reporting, okay, consumer privacy, and also financial fraud. So I've just given a sample set, and this is how the graph looks in real life, in the sense that when you're actually solving a specific problem, you basically want to visualize that information in the way it is represented here, and it's very easy to follow. And that's why I try to use a graph. Excellent. I hope this answers your question.
Absolutely. That was very insightful.
Thank you, Deepak.
And second question, in fact, was asked to me only yesterday. And the question goes like this: what are the key advantages of using graph database over RDBMS?
So if you look at this slide here, when you see the way graphs are being used, okay, and the reason why graphs find a better use over relational databases. Primarily, relational databases came into major usage about 25 or 30 years ago, I think around that time, where the world started growing in terms of number of transactions that used to happen, where boundaries were crossed and large number of organizations started having multiple warehouses, multiple delivery points. So transactions became the key, and extensive transaction reporting started to happen. And that's where relational databases came into play. So when it comes to extensive transaction reporting, what happens is you get into a situation where you need tables and columns and rows to fetch that information and store effectively. But after this usage of extensive transactions, the world basically decided to find out what is the knowledge that I can get out of the transactions that have been created. Essentially, you and me today know very well that these transactions do not get created in an isolated fashion. They're not just born out of nothing. Okay. Yeah. So if there is a simple transaction of me buying something from you and you raising an invoice, it's basically some discussions that must have happened, a deal must have been struck. So this background information and knowledge is what resides implicitly within those transactions, and which needed to be captured for the enterprises and companies to figure out what they can do better, how much more efficient they can make their systems. Okay. And that's where graphs became useful. So graphs basically find out these connections in a very, very quick way. In fact, the advantage of graphs over relational databases instantly is for the traversal that they do within a very, very large data set compared to what it would take a relational database do. And that's essentially the first and the foremost difference in terms of traversals and connections, which can be traversed at multiple levels. So this essentially forms the key difference. And thereafter, when you get into the data mining and when you try and figure out the patterns and when you try and figure out the different algorithms, which can be used extensively to mine these patterns and also find out how many patterns are similar, how many patterns differ from each other, graphs basically generate results and solutions to an extent far exceeding the expectations one would have had they been using relational databases. I hope that gives you a clear picture in terms of why GraphDB over RDBMS.
Yep, great. All right, third question that comes is from one of our partners. As a practitioner, how do I know when our graph database is a good fit?
So again, graph databases over relational databases or graph databases in use cases. So if I go back to my first slide where I had shown the use cases where graphs are being used, so you can draw reasonable conclusions as to where and when graph databases start becoming important to us in our organizations or the institutions where we belong to or where we work. Mm-hmm. So the data needs to be, the data in normal situations is always connected. So in order to define and find the connections between this disparate set of data sources, graph databases come into play extensively. So where would I use graph databases? Wherever I'm interested in the connections, wherever I'm interested in the patterns that are generated out of these connections, graph databases would become useful and important to me. So in a simplistic way, that is where graph database becomes useful, or that is where graph databases are used extensively. So if I go to the other slide where we can see the local patterns versus global computation. So essentially, when you start looking for the different connections and the embedded connections or the implicit connections or the connections which do not figure out in the normal transactions, you basically look for these and you find out certain patterns. And then you can use a pattern construct and use simple mathematical algorithms and figure out how these patterns exist within the larger graph databases, larger graph data that you've collected. And that's where graph databases become extremely and exceptionally useful to you.
Excellent. Thank you so much for answering that. The next question comes is how do we get data loaded into Graph database quickly?
So, so let's look at the way data initially moved into relational database when they came into being the first time. Okay. So
Yeah.
I do not know if you were aware, but at the time when I started my career, we were using COBOL, which was extensively used for transaction management system. Now, COBOL basically stored data in a very simplistic flat file formats. Okay. And there was this question of how to move such large COBOL data into relational database because they had a different structure. So a lot of work was carried out, and later on it was reasonably simple to move large tracts of data into COBOL, from COBOL to relational database, and then the world became relational database. So the same question comes up here, where how do I move my data which is residing in different kinds of databases or different kinds of data sources? How do they move it? So there are three simple ways we look at when we move data. One is what is natively available in our graph engines, which can read data in a very simplistic format and move them. So the basic way of transacting or moving data into a graph database is a comma separated value list, okay, which we call as CSV files or delimited files.
Mm-hmm.
So that's the first format through which we move data into a graph database.
Okay.
Then comes the second part where people become a little more evolved, or systems become a little more evolved. The concept of writing device drivers or writing drivers come into play. So we have drivers for different databases where the graph database using the drivers can read directly the data from there. The third set, which basically comes from the concept of streaming data. So you have large sets of data being streamed into a system, which is essentially, say, your news feeds or other kinds of streams data. You have systems which basically convert these streams into acceptable formats for the graph data to ingest. So that is the third set, the third way of doing it. So all these three combined basically form the criteria for you to figure out which one suits best for your environment and pull the data in. Last but not least, where a lot of work is being done and a lot of work has already been carried out, is something known as the ETL. Okay, so extract, transform, and load. Now that concept basically was born out of this requirement where you got data, but you still needed some kind of transformation, some kind of a cleaning, and then finally move the data into a data source or a database. So ETL solutions are available, ETL softwares are available, which additionally help you to move data from a disparate or a different kind of a data source into a graph database. Does that answer your question?
Yep. All right. So one question that comes to my mind, and this is my question: can we have a graph layer on top of a RDBMS?
Oh, that's a very good question. Is the graph database essentially can coexist and should and will coexist with relational database for a few more years. Reason is very simple, that the relational database primarily is required for collecting transactions, and this world is basically people always have transactions to convert a relationship or convert a deal into something. So that's when the transactions come into play. So data will lie in transactions to a large extent, and over it, on top of it, you'll have different data sets which will basically build your relationships. Okay, and the graph database is going to be used as a conjunction of both these systems, or these systems put together, and will give you an insight in terms of what you essentially need to achieve in terms of doing your business more efficiently, spreading your business, or probably getting more customers into your fold and growing your business, or even acquiring new businesses which have something relative or something which adds value to your business. So for that, you would need a graph database. And yes, they should and they would lie alongside each other rather than on top of it. I would admit to a fact that they can coexist, but you could have an abstract layer of a graph database which pulls out the insight out of the transactions you've done.
Okay, great. So the next question is about insights, as you just mentioned. So how can the insights and actionables be made simpler for me to take action?
So when I showed you the graph database, and when I showed the graph construct in my when I actually ran a requirement of where all graphs are used, I can actually flip the screen to show that this is exactly how the graph looks. Yes, that's one. Sorry, Deepak. So can you see this slide?
Yeah, I can see it.
So if you see, look at this slide, this is exactly how the graph works. So if you have these actionables and results or decisions to be taken, you are going to be using something like a mind map, and the way our minds work, okay, when they connect different things together and carry out actions depending on where that information is coming from and what source is it coming from and where it is need to be directed to. So if I look at this graph and I double click, say, financial services, and the graph as it pans out in front of me gives me a very easy view or easy method in terms of realizing my next steps. Okay. So now I come back to my slide deck where I can, where I'll show you the global computation versus the, one sec.
Yeah.
The global computation versus the local patterns. So typically your actionables get determined and defined when you look at a certain local pattern and you feel that probability of that pattern residing in my graph could be higher, or probably these patterns are going to be repeatable in some way. I would typically look at some kind of an analysis on top of that pattern set. Okay. So my actionables are stepped through that I determine or find a pattern, look for them in a global way. I compute them globally using some algorithms, which the algorithms, I can tell you what are the typical algorithms. And as soon as you read their names, you would realize that these algorithms probably people use even without naming them in our regular work.
Yeah.
Okay. So community detection, it's quite simple, where we use our own methods to define a community of people or maybe some kind of interest groups. So these communities have certain algorithmic way by which they can be determined, and how they can be used is basically the connected information provides a backdrop. The connected information stored in a graph provides a backdrop for these algorithms to be conducted on them. So all of them put together makes your life extremely simple in terms of harnessing the insight out of the graph, or converting your references or inferences into real actionables and what you may, I mean, in the sense in terms of delivering a solution or in delivering in some kind of a result out of this entire exercise you've done.
Okay, great. Thanks a lot. All right. So the next question is, how to convert a graph database into a knowledge graph?
So graphs inherently, the nature by which they are made, the nature in which they are made, basically answers one very simple question: what we need for scale and what we need for knowledge graph. So knowledge, as we all know, is evolutionary. It grows along with us as we grow. So knowledge is never static. So graphs basically provide you this advantage of being able to evolve as you move along or as you grow. So as your business grows, or as your method of doing business grows, or even if you acquire a new business, there is a lot of evolution that is likely to happen within the organization, within the supply chain, within the customer base, and all those activities, including your accounting systems. So when this evolution happens, you would need a system which is readily capable of pulling in all of this information together, and yet not being subjected to a lot of delays in terms of responses. So graphs basically allow you to do that. So they can evolve as your business grows along. You can add new components to a graph. So a graph basically consists of three very simple parts. So one is the node, okay? Then you have something called the edges of the relationships. And for the nodes and relationships, you can store properties which are key value pairs. Okay. So you just have these three fundamental pieces which define and control a graph. Now, all of this can grow as you move along. So scalability is inbuilt. Okay. And since graphs do not use indexing to the extent the other systems use, you can traverse a very large graph in extremely quick time. So that means you can have billions of nodes and relationships in your graph, probably, but you could have traversed it within milliseconds in terms of reaching your goal. So that's where the scalability comes into play automatically in terms of searches. And while growing, the evolution part allows the graph to evolve in a way that you can always evolve. So it doesn't stop you. So I think these two areas basically define the scalability part that graphs today provide.
Okay, great. All right, so you have been a practitioner of graph databases for quite some time now. So this is one question that has been asked is, are there any challenges of working with the graph database? And if you
Yes,
have
couple of challenges, Deepak. I agree. I mean, no new systems come with a feeling that you'd never have any challenges to overcome them or know them better. So people who have moved or transited from other systems into graph databases, first of all, have to start wearing the graph database cap. So they have to think graph. They have to think mind maps. They have to think the way we think, rather than the way the machine was basically made to think earlier. So if you come with a relational database mindset and try to apply it in graph, you'll feel or you'll be inundated with a few challenges. So that is one. So that is basically a personal situation where it comes into play, where you have a thought process and you have to unlearn it while to get into graph. But once you're in the graph systems, okay, what are the other challenges you can confront? So you've asked me this question, the earlier one, how to move the data into a graph. So obviously, when you create a graph, your data may not be residing in graph. Your data is already created and residing in some other data sources. So the challenge that immediately comes into play is, how do I move that data? But I think that has been taken care of. Extensive tooling, extensive methodologies, and simple native structures have been used for moving the data into the graph database. The third part, which becomes very important, that once you have data in graph, how do I visualize it? How do I show it to my customers? How do I see it myself? Okay. And that's where the visualization piece comes into play. So graphs allow you, graph databases systems come along with them. They have visualization constructs, and the visualization pieces add value in terms of how to show the data to the customer or to your end user or to yourself when you're trying to analyze the graph. Okay. So these are the three challenges which come. Last but not least, but which is just caught on, is basically the situation where, how do I use the graph in terms of patterns searching? Okay, so you have algorithmic searches, and I showed you some of these algorithms which are in play. And in the finality, okay, the biggest challenge which I have seen where a lot of people encounter is, how do I model my graph? Okay, what should essentially be my graph? I mean, we've been talking graph, we've been talking relational database, but we go back to our school and we said, how did I create my first table of data in a relational database? What was this name? What was the name of the table? I said, okay, it was customer. What did I put in the customer table? Okay. What did I put in the employee table? What did I put in the salary table? So graphs basically answer some of those questions in the same way. So you need to know what is it that you want to graph. So it comes out of the fact that you have a problem wherein your relationships matter a lot more to you than the transaction parts. And these relationships are inherent, implicit, directed, undirected, okay, categorized. So you need to get a graph model which depicts that problem space or the use case. Once you create that model, okay, things start fitting into it much better. But if you do not create a model, or if you're not able to create a relevant model to your use case, you will have certain challenges in answering those questions.
Okay, great. Okay, you in this session earlier you mentioned about the fast travel sim, right?
Correct.
That is one capability of the graph databases.
Correct.
So what is that makes it travel so fast?
So it's a very simple slide. I think you can see it, right?
Yeah, I can see this.
So we as human beings, when we, like when I was in Bangalore, and if I had to reach your house, I would probably know exactly how to reach your house, right?
Yeah.
But if you go to a relational database, or if you go to some other kind of information systems, in order to access some other address or some other information, I probably go into some lookups. I go into a lookup table, I go into a index table, I go into a hash set, and I try and look up that information in that hash, pick up the address from there, and then go and fetch that information.
Yeah.
Okay. So it basically consumes a fraction of time, but when you multiply this fraction of time across millions and millions of data to be retrieved, this adds up. Okay.
Mhm.
Now, the graph does the job in a much simpler way. The graph stores the address, the next address, the following address, and the address which it has just left with itself. Okay. So the
Okay.
graph entity is able to traverse that much faster without really having to go back and do a lookup.
Okay.
So those of us who have been in with computer science or have done some work in computer science and information systems must be very, very sure about what linked lists are.
Yeah.
So a graph database is essentially a very large linked list.
Okay.
Okay. And in fact, it's a doubly linked list, if you may, to start with.
Mhm.
And that's how the information can be traversed much, much quickly, like the way the memory addresses get traversed while you try and fetch data from memory.
Okay, great. So one last question, which is the most popular of graph databases that are available in the world today?
So Deepak, there are multiple databases, graph databases that are available. Some of them are also available in a form of what you call open source, and some are commercially available. The most what you call known database, graph database that is available in the world today and is known to a lot of people is Neo4j. But I would essentially say that every graph database has its capabilities and inherent features which have usage in different areas of work. Okay. So when you ask me this question, since we are a graph practitioner and we use Neo4j extensively, we would say Neo4j is a good graph databases to try and look at. But there are other multiple graph databases which one should look at. Okay, so I'm just showing you the Neo4j graph database architecture. If you can see it over the slide on the screen, essentially, in a very simplistic way, it kind of addresses the problem space in a very refined and a simple way, and it works well with a large set of application stacks, data stacks, and including a lot of visualization tool. So the architecture delves itself very well into the current enterprise infrastructure.
Okay. So Sridhar, this is all that we have for today. Thank you so much for taking time out of your busy schedule and answering all these questions. And for our audience, I would like to say this is just one of the sessions that we have planned. We are planning more such sessions as we go forward into this new year. And keep watching this space. Thank you so much for watching, and bye-bye for now. Thank you,
Thank you,
Sridhar.
Deepak. Thank you. Thank you.